HiWayCAD. Label story and measurement unified. The story of the labels.
The texture of a three-dimensional object is processed uniformly on all its faces, treating them equally. Historically, the design of HiWayCAD's labels was long constrained by this reality. This was version 1. The side effect of applying labels to all 6 faces of the basic panel material became apparent. The label on the back face was reversed. The labels on the 4 side faces were scaled down so much that the text was illegible, appearing instead like stains. This year, a comprehensive upgrade utilizing AI involved clarifying concepts and establishing dynamic textures. These textures are only applied to the front face of the panel material, with the back and side faces receiving no texture. This solved the label confusion. This was version 2. When the work progressed to creating holes openings, a new problem was discovered. The system framework had an error, causing the labels in version 2 not to display. Various AI models were tormented for about 10 days over this issue, but ultimately, they could not help. Consequently, a breakthrough idea was needed, exploring an alternative approach. The final consideration was to spiritually separate the label from the panel. This involved not placing the label texture directly on the panel, but rather on another independent, transparent entity. This transparent entity was then attached to the panel. This was version 3. Later, when the work reached the point of creating several small circular grooves in the left and right main panels to support a partition, version 3 also failed. The critical issue was that none of the errors were code logic errors. Therefore, there was no error message. The AI went from being unable to help to refusing to work. This forced the programmer to use the last resort, deleting code in segments to determine exactly which part of the code was causing the problem. This is a very clumsy method. This is also a method used when there is no other way. In fact, even the clumsiest method is infinitely better than no method at all. Indeed, the deletion test confirmed that the attachment was the problem. The issue disappeared as long as the label was completely independent. However, once the panel and the label were completely divorced, the label had to be positioned to still appear as part of the panel moving, rotating, and scaling synchronously. This was version 4. Considering that versions 2, 3, and 4 these 3 sisters each have their own merits, the decision was made to adopt them simultaneously. Different versions will be used for different scenarios.
Unified measurement.
The content of the labels for 3D models includes the number and dimensions. The core of a 2D construction drawing is the dimensioning of the object. The editing items in the target module are limited to modifying dimensions. The position and size of openings also imply dimensions. All dimensions should be unified under the corresponding international standards. In engineering, the internationally unified unit of length is the meter. The meter is the base unit in the International System of Units (SI). The SI is widely adopted globally in fields such as science, engineering, and commerce, aiming to standardize weights and measures. Its significance is comparable to the unification of writing, currency, weights, and measures by Qin Shi Huang in Chinese history, intending to achieve written language the same, tracks the same. The international standard for dimension units is the metric system. In engineering, measurements are taken in millimeters millimeter. Only the United States, Liberia, and Myanmar still use imperial units. The U.S. Congress legalized the metric system in 1866 and passed the Metric Conversion Act in 1975, but did not mandate conversion. Consequently, conversion primarily occurred in science, medicine, and industries related to international trade, while the imperial system still dominates daily life. This is because all factory machinery, tools, screws, and nuts are manufactured to imperial specifications. Mandatory conversion would mean replacing or adjusting millions of industrial equipment units, road signs, packaging sizes, and educational materials, incurring huge economic costs. Considering that the construction and engineering sector uses the millimeter, a metric unit for measurement, this application unreservedly chooses the millimeter for expression. The value is rounded to the nearest integer, as the fractional part is not practically significant. Naturally, the imperial unit will also be considered for addition in the future, based on customer demand. Despite this, the application still uses the decimeter within the system. This is the unit of length most suitable for 3D simulation.